Hi students, good evening and welcome to this network sum of sessions. Today is session number 3. Okay, so in the continuation of series, in the last class we have completed the network theorems and some part of inductor and capacitors I have touched. So today some more segment of this LC were left out, so let's discuss them. And then we'll be switching into the most important topic of gate, that is your transient network analysis. So in the first questions, so the question is something like this. In the circuit shown below, IST is given 4 sin 4t, okay? So it is 4 sin 4t. The ICT will be, so this is what your ICT is. So this source information is given and you are supposed to find this ICT values. So how do you get it? The logic is simple. How do you get it? You know, in a capacitor, the current is given by ICT is equals to C into dVCT by dt. Isn't it? So in this case, if I ask you what is VC, so this voltage your VC. And if you see, this VC is nothing but equals to 3 VLT, because so this source is in parallel with the capacitors. So I can say the voltage of the capacitor is same 3 VLT. But what is VLT? VLT is defined here. Okay. And you know, VLT, that is the voltage across the inductor, is given by the formula L into DIL by dt. So what is L? L is 0.2 and IL. What is IL? In this case, if you see, so this is what your current is IL. So what is ILT if I ask you? Your ILT is equals to IST and that value is nothing but equals to 4 sin 4t. So in this case, I can tell that the ILT values is equals to IST and that equals to 4 sin 4t. So you have to substitute this value in these equations. So VLT equals to 0.2 into d by dt of IL. So what is IL? This is 4 sin 4t. So if you simplify this, so 0.8 into 4 you'll get, right? So how much you'll get? 0.2 into 4 is 0.8. 0.8 into 4 is 3.2. 3.2 cos of 4t, because differentiation of sin 4t is 4 sin, difference sin 4t is 4 cos 4t. So 16 into 0.2 is 3.2 and this is cos 4t. So this is what your VLT is, right? So if I substitute in these equations, this is C into d by dt of VCT. What is VCT? 3 VLT. So 3 VLT means 3 into these things. So this is 9.6 into cos of 4t. And C value is also given to us. So what is the C values? C value is given here 0.25. So 0.25 into 9.6 and differentiation of cos 4t is minus 4. This is sin 4t. So this is minus of 4 into 0.25 into 9.6 into sin of 4t. So 4 into 0.25 is 1 and overall if you see the answer is minus 9.6 sin 4t. So which is given in option D. So it's a simple questions, but such kind of questions, if you see the past papers, it has been asked, and from last 3-4 years, they haven't asked questions on this model. Okay, so you can expect a questions in the upcoming GATE 22 exams, somewhat similar to this, where you just have to use the voltage current equation of the inductor capacitors. In these questions, the thing what you need to find is what is CAB. So what is the value of equivalent capacitance from AB terminal? Okay. So what is it? So this question looks very simple, like we have this series parallel capacitors, and yes, it is. But still, let me see how many of you are answering it. I'm giving you around 20-30 seconds of time. So in that time, you should be able to tell the answers. Tell me. So what is CAB in this case? What is CAB in this case? Any idea? How do you solve it? So one thing I can tell, this 8 and 12, so these are in series. So this equivalent capacitance, if I ask you how much is it? So this is 12 into 8 divided by 12 plus 8. Similarly, this 4 and 8, so these two are in parallel. So whenever capacitors are in parallel, we have to add their values to get the equivalent capacitance. If 4 and 8 are in parallel, so the equivalent capacitance you'll get is, this is 12 microfarad. And this 12 is in series with 4. So if I ask you, what is this entire thing? Okay, so this becomes 12 into 4 divided by 12 plus 4, which is 48 divided by 16. So that is 3 microfarad. So very simple, right? So first I reduce this 4 and 8. So they become a single capacitor of 12. Then and 12 and 4 are in series. So now, if I ask you to draw this circuit now, whatever I have simplified yet, so this will be something like this. So this capacitance value is 3 microfarad. Then you have this 24, okay? Then you have this 16, okay? So then what? Then this is 16. Then this is a single capacitance whose value is how much? 8 into 12, 96, 96 by 20. So this is 96 by 20. So this is 3 microfarad. This is your 24 microfarad. 24 microfarad. And this is your 16 microfarad. Okay. So 12 into 3 microfarad. So you can say this is what is this scenario. So this is your A and this is your B. So what is it? How much you'll get? Anybody? What is the answer? Now you simplify this CAB, okay? I mean, if you see this, so now this can be solved using simple series parallel combinations. So this answer, what you're supposed to get is 8 microfarad. Please check it out. So this is one way to answer this, okay? Otherwise, I mean, if you're not getting this, okay, so you might do step-by-step solutions. Okay, so what is the step-by-step solutions? Other way, if you see, so what you can say is, so you may not, okay, so let me do, I mean, this is one way. I mean, if you redraw it, you'll be getting the answers. Otherwise, what you may do is, this is something like this. So this 4 microfarad I am keeping as it is. So this is your 4 microfarad. Okay. So across this 4 micro, if you see this one, so this AB is asked from this 4 microfarad terminals only. That means A is connected to one end of 4 microfarad, B is connected to other end of 4 microfarad. So this, now I can redraw, it is something like this. So this is your A terminal and this is your B terminal. Okay. Then from this AB terminal, you have these 16 and then you have this 8 and then you have this 12. This is 8, this is 12, this is 16. Now these two 4 and 8, so I can replace it by 12. So this I'm replacing it by 12. And this 12 is in series with 24. Hopefully this makes sense now, right? I mean, earlier also it was okay, but now I think this is giving you more clarity, right? So without being jumping into multiple steps, step by step, if I do. So first, this 4 microfarad, I kept here. Then this 4 and 8, 12. So this is 12. Then 12 is in series with 24. And then you have this 16. And then 8 and 12, like this. Now, basically, I am supposed to find the capacitance from this AB terminal. If you see from AB terminal, okay, so how do you simplify it now again? So one thing I can tell that this 12 and 24, you can see here. So this 12 and 24, they are in series. So this I can further replace it by a single this one. So because this 12 and 24 are in series, so let me replace it by a single capacitance. So what is the capacitance? So 12 into 24 divided by 12 plus 24. So if you do that, so that answer what you're going to get is nothing but equals to 8 microfarad. So that answer is 8 microfarad. Now, do you agree that this 8 microfarad and 16 microfarad in parallel? Yes. When two elements are said to be in parallel, if they are between the same pair of node. So if I say this is node A and if I say this is node C, okay. So, one second. So if you see these two elements, okay, 8 microfarad, 16 microfarad, one end is this node. Let's say if I'm saying this is node C and the other end is A. This node is A only, right? So they are between node C and node A. So they are said to be in parallel. If they're in parallel, I can tell 8 and 16, the parallel combination of that is becoming 24 microfarad. So this parallel combination is equivalent to 24 microfarad. Now, if I replace it, so how do I get? I mean to say, so this, okay, so you may draw like this. If it is okay for you, you may further simplify the circuit, something like this. So this is 4, it was, right? So now this is equivalent to your 18. This is 16 and this is 8. So this is now equivalent to, okay. So you have, this is 16 plus 8 is 24. This is in series with 4. Okay. This is in series with 4. And then this side, you have this 8 and 12. 8 and 12 equivalent is 96 divided by 20. And from where we are finding this CAB? We are finding this CAB from this 4. Okay. So this is your CAB. So if you see this CAB is equals to, you can see here. So from this point, there are two paths. One path is this 4 and other path is this segment. So there are two paths. One is this path and other one is this path. So this is equivalent to 4 plus. So this is equivalent to 4 plus, okay, 24 into 96 by 20 divided by 24 plus 96 into 20. Yeah, you simplify this. So this answer is supposed to be 8. So this is 4. If I multiply 20, so this is 24 into 96. This is, if I multiply 20, this is 24 into 20. How much it will be? 24 into 20 is 48, 0, plus this is 96. You simplify this, so this answer will be coming as 8 microfarad. So this is what is the step-by-step solution to this particular problem. The circuit is looking so simple, okay? And just I have done this I have redrawn the circuits because directly series parallel combinations is not visible, right? So by following step by step, we are able to reach this conclusion. This is one of the best question, okay? One of the interesting question as well. So I'm giving you a 5-star. Such kind of questions which is related to energy and power, you may expect in the upcoming GATE exam. Because last time they have asked it, I think before 4 or 5 years, but now I think it's the time that you may expect questions somewhere from this model. It's a very nice questions. Let's see. And unless until you are not good in the concepts, so such kind of conceptual question you may not be able to answer. The question is, in the circuit below, 2 series connected capacitors 3 microfarad, 6 microfarad, having initial voltage 4 volt and 6 volts are connected across a black box at t equal to 0. So they are saying this is a 3 microfarad capacitor, this is a 6 microfarad capacitor. Their initial voltage is 4 volt and this initial voltage is 6 volts. It is also given for t greater than or equal to 0, the current IT. So this current IT is 20 into e raised to power minus t microampere. So the question they are asking is, the total energy delivered to the black box will be how much joule? What is the energy that will be delivered to the black box? That's question number 1. Question number 2 is, the energy trapped in the ideal capacitors will be equals to how many joule? Okay. So please try to answer. Okay. So there are 2 questions in this. The first one is, what is the energy delivered to the black box? And what is the energy trapped in the ideal capacitors? Okay. So please try to respond this. It's a good thinking based questions. So hopefully you can answer. So what is the approach in this case I'd like to use is, so I'll be replacing these 2 capacitors which are in series by single capacitors. So if 3 and 6 are connected in series, their equivalent capacitance is 3 into 6 divided by 3 plus 6. That is 18 by 9, that is 2 microfarad. So this is 2 microfarad. And if I ask you what is the voltage, so this voltage is 4, this voltage is 6. So the initial voltage in this case, I mean, if I ask you what is this initial voltage from this terminal, 6 plus 4, that is 10. So I can tell. So this circuit is equivalent to a single capacitors of 2 microfarad, which is carrying the initial voltage of 10 volts. Then if I'm interested to draw the circuits for, t greater than 0, so the switch is closed for t greater than 0. So I'm closing the switch. And this current IT is also given to me. And that IT is 20 into e raised to power minus t microampere. That's what is given here. And this is what is your corresponding black box. This is what your corresponding black box. So what question they're asking? The total energy delivered to the black box will be how many joules? How many? In microjoules. So this is what is my black box. So the initial voltage of the capacitor is 10 volts. So you know the currents, okay, and we know the capacitance 2 microfarad. So the question is, what is the total energy delivered to the black box? So how do you calculate what is the total energy delivered? Any idea? Can you tell me at least the equations? What is the equation we should be using in this case? So you know very well one of the universal relations that energy is always integration of power. Energy is always integration of power. And what is this power? Power is product of voltage and currents. So V into I into dt. So if you want to have the total energy, the limit of the integration should be from 0 to infinite, because the switch is getting closed at 0. And total energy means, so in the extreme case, the upper limit can be infinite. So I'll be finding the VI products and I'll be integrating it over the limit 0 to infinite. And we'll see how much answer we'll get. That is what is your total energy delivered. And then we'll come to the next question. So let's first try to get this. So the current information is given to me, but I need to have the voltage information. So what is voltage? So, if you have a capacitor like this, so this is C. So this is what is your VC. This is what your IC. Okay. Then in such kind of situations, so the value of the voltage VCT is given by 1 by C. Okay. I mean, one case you can write like this. Okay. 1 by C integration minus infinite to T. Then this is your IC tau d tau. So this is equivalent to your VC0, I mean the initial voltage of capacitor, plus 1 by C, integrations from 0 to T, and this is your IC tau d tau. This is what is the technique is. Okay, but you note here carefully, this is the situations if the current is entering from plus to minus. If you observe this, so the current is entering from plus to minus now, this IC entering from plus to minus. But if you observe this particular question, so I mean in my particular circuits, so here this current is entering from minus to plus. So do you think we have the same thing here? No, there will be a change. And that change is nothing but instead of using this plus sign, so this plus sign will be minus sign here. Hopefully the logic is clear. Why I am using the minus sign? Because the current in this circuit is entering from minus to plus. That's why this is not plus sign. So this will be your minus sign. So by using these equations, first we have to get what is this VCT is. So now if I simplify this, so your VC0 is your 10. Okay, this is your 10 minus 1 by C. So 1 by 2 microfarad, 1 by C. Then limit is 0 to T. Then this is 20 into e raised to power minus T. This is dt. So there is no point to write this microfarad here because even the current is in micro. So micro will be cancelled out. So if I observe this, how much you'll get? This is your 10 and this is minus 10. Okay, 20 if it comes out. Then it is e raised to power minus T divided by minus of 1. And the limit is from 0 to T. So this, if you see, this is 10 plus, so 10 into e raised to power minus T minus of 1. So this is happening to be 10 plus 10 into e raised to power minus T minus 10. So 10 cancel out. So how much you are getting? So this answer, how much you are getting is 10 into e raised to power minus T. So that means, so from the given data, okay, ICT was given. So now we are able to get VCT. And the value of VCT is nothing but 10 into e raised to power minus T. So again, it is in micro only because all the data is micro. So this will be also in micro. Okay, but what is my requirement? My requirement is to get the energy. Karthi is asking if the polarity change means are in the energy capacitor sum. Yeah, polarity change means in this case, my point was, I mean, whenever you are writing this kind of relation, okay, so in these relations, it is assumed that the current is entering from plus to minus. But in my questions, the current is entering from minus to plus. So if you want to give this data in the equations, so there will be definitely a negative sign. If the current would have been in this directions, then I could have used again the plus sign, no issues. So this is a key point in the question, okay? You shouldn't do this mistake. Okay, so I got VCT. So now let me try to get what is the energy. So energy is equals to integration of 0 to infinity VCT into ICT. Okay. So this, if you simplify, how much you'll get? So your VCT values is 10 into e raised to power minus T, and your ICT values is how much? It is 20 into e raised to power minus T, right? 20 into e raised to power minus T. So this dt, and the range is from 0 to infinite. So 10 into 20 is 200, and if you integrate this, this is e raised to power minus 2t divided by minus 2, right? And the limit is from 0 to infinite. If you simplify this, so this is minus 100, and then it is 0 minus 1, so which is equivalent to 100 microjoule. which is equivalent to 100 microjoule. So that means, so this is what is the total energy delivered to the black box. So the total energy delivered to the black box in the range, the time 0 to infinity is how much? 100 microjoule. So the answer of the first question is 100 microjoule. Now, how do you answer the next question? So to answer the next questions, so the question is, what is the energy trapped in the ideal capacitor? What is the energy trapped? Okay. So what we understood in the first question is this much of energy, that means 100 microjoule of energy is delivered to this black box in the range of 0 to infinite, time t equal to 0 to infinite. So if this much of energy delivered, from how much energy this much is delivered? So whatever the initial energy the capacitor was carrying, whatever the initial energy this capacitor was carrying, so out of that, 100 microjoule is delivered to the black box in the range of 0 to infinite. So initial energy of this capacitor minus 100 microjoule is nothing but the energy trapped in this ideal capacitors. So if I do that way, so what you have to do then, you have to first find what is the initial energy. So initial energy means what is the energy of the capacitors at t equals to 0. So this is equivalent to how much you'll get. That is half C1 V10 whole square plus half C2 V20 whole square. So which is equivalent to half of, what is the value of C1? C1 is 6. So this is 6 into 6 square, again plus half into, so 3 into 4 square. So 3 into 4 square. Excuse me. This is 3 into 4 square. So if you observe, what is the answer you are going to get from this is coming 36 by 2 is 36. Okay, 3 into 36 is 108. 108 plus 24. This is coming 132 microjoule. Okay, so this is 132 microjoule. So 132 microjoule. 132 microjoule is the initial energy, and from that 100 microjoule is what delivered to this black box. So 132 minus 100, that is only 32 microjoule of energy is getting trapped in this capacitors. Okay, so this was carrying 132 initially. Out of 132, 100 it is delivering, and remaining 32 it is what? It's holding, or it is getting trapped. Okay, so similarly, there is one more questions which is related to inductor. Where is that? But the point is, this is what you solve this kind of questions. If you get something like this, so this is what the logic, and the main key point in this question is that most of students will do mistake by forgetting this minus sign. You should be logically good to tell, okay, this should be minus sign. Okay, so this is again one of the most popular model questions. So very frequently in the GATE exam, we are getting the questions like the voltage current waveforms will be given. Like either voltage will be given, they'll be asking you currents, or vice versa. So this question is, the voltage waveform shown in the figure is applied to a 4 microvolt capacitor. The waveform of the current through the capacitor will be. Okay. So what is given? Voltage is given. You need to have the current informations. So the relation ICT is equals to C into dVCT by dt. So your C is, in this case, it is 4 microfarad. So this is 4 microfarad, and then d by dt of VCT. So the VCT is given to you. So if you observe this one, which option is correct, you think? Any idea? By observing the question itself, you should be able to tell the answer. So you know very well, differentiation always gives this slope. Differentiation always gives this slope. Okay. So if I observe this VT waveform, So this is a straight line, this is a straight line, this is a straight line. And each straight line will be characterized by its slope. So if I ask you, tell me what is the slope of this? So the slope of this is 12 by 4, that is 3. But it is falling, so it should be minus 3. Minus 3 is the slope of this. If I ask you, tell me what is the slope of this? So slope of this, if I ask you, then it is in this case, how much? The height is 12 and the width is 6. Right? So 12 by 6, this is 2. And what is this? This slope is basically 0. So naturally, if I differentiate this, if I'm differentiating this, if I take the limits, this is 0, this is 4, this is 6, and this is 12. If I take like this, so from 0 to 4, the slope is minus 3. So you get here minus 3. Then when 4 to 6, it is 0. So you get it is 0. Then when 6 to 12, this is 2. So it is 6 to 12, it is plus 2, right? So you get something like this. So this is your plus 2. But you have to multiply this 4 externally, right? So if you multiply this 4 externally, this minus 3, this become minus 3 into 4 is minus 12. This 2 is becoming 2 into 4 is 8. So if you observe, the option D is correct for this. So minus 12, then 0, and then it is 8. That's what is the answer. The option D. Very straightforward questions. So this question is based on the differentiations. So the next question I have taken is from the integrations. So such kind of questions are very popular. Okay. So, you have to just, you should have this skill to, how to do the integrations and differentiation. That's it. So in these questions, you see here, the voltage VT shown in the figure below is applied across a 0.5 Henry inductors having initial current of how much? Minus 2 ampere. Which of the following plot is correct for the inductor currents? In the previous case, what? Voltage was given, current was asked. In this case, in the previous case, voltage was given, current was asked. In this case also, voltage is given, current is asked. But in the previous case, it was the differentiation relations. In this case, what relations it will be? So in inductors, you know very well, current. So if I say the current is ILT, so ILT is given by integrations. This is 1 by L, integration minus infinite to T. This is VL tau d tau. So this is equivalent to 1 by L, integration minus infinite to 0, VL tau d tau plus. So this 1 by L is, okay, anyway. Plus, again 1 by L, integration 0 to T. This is VL tau d tau. So the first term here, okay, so the first term here is nothing but your initial currents. So this current we call, this is IL0. So overally, if I ask you to write what is ILT, so your ILT is IL0 plus 1 by L, 0 to T. This is VL tau d tau. So this is what your ILT relation is. Okay, na? So in this case, your initial current IL0 is given to you, which is minus 2. So you have to add this factor minus 2. So you have to add the factor minus 2. And then you have to multiply this factor 1 by L and you have to integrate the corresponding VLT graph. So what is the integrations? Integrations always gives the area under the curve, isn't it? Integration always gives the area under the curve. Now, if I ask you to integrate it, so what do you get? So you see here. So let me give you some idea. Then you can easily catch my point. So we'll see this minus 2 later. But for the time being, let us first try to integrate. So now you see here, this is your 0. This is your 0.5. The next is 1. The next is 1.5. Next is 2, and so on and so forth. Now, if I'm starting from 0 to 0.5, so what is the amplitude at 0.5? There is nothing but the area of this graph till 0.5. So what is the area of this graph till 0.5? So width is 0.5, height is 1. So 1 into 0.5 is 0.5. So that means, so this you will touch to this 0.5. So this height is basically 0.5. Then once you are touching this 0.5, now from 0.5 to 1, this will be same 0.5 only. This will be same 0.5 only. Why? Because once I have crossed this 0.5, now from this 0.5 till 1, okay, so there is no area you are accumulating. So whatever the area you are holding till 0.5, the same amplitude you are continuing. So this is what is happening till 1. So now if I'm crossing this 1, then again if I ask you what the amplitude at 1.5, it is again the net area of this function till 1.5. So till 1.5 means again from this you got the area 0.5, again you'll have 0.5 here. So 0.5 plus 0.5, this become 1. So this amplitude is basically 1. Again between 1.5 to 2, this is 0. So you continue the same this thing. So if you are only integrating this one, okay, so this is what is the pattern you're going to get. But what is the modification I need? I have to multiply this 1 by L factor, one thing. And second thing is I have to add -2. So what is the inductor value given? Inductor value is 0.5. So if the inductor value is 0.5, so what is 1 by 0.5? 1 by 0.5 is basically 2. So here it is 2. So if you are multiplying 2, so this amplitude which is 2 into 0.5, this become 1. This amplitude which was 1, now this become 2. So this is what is the overall, I mean, if I ask you what this waveform is, so this is basically this particular term. So in this, you have to add this -2. If you're adding -2, so what it means, the overall waveform will be pulled down by 2, right? So like what you used to do in case of the, what I can say in the clamper circuits, in analog circuits, it used to introduce some DC. So similarly, in this case, the overall waveform will be pulled down by 2. So if the overall waveform is pulled down by 2, so what is the answer you're going to get then? So any answer? Anushka is saying it is option D. Is it option D? So this point will be going to -2. This point will be going to -1. Yes, it is option D only. Okay. So you just think like you are just pulling down this waveform by 2. So this point 0, okay, which is 0. So this will come to -2. This point which is 1, this is 1 minus 2 is -1. This point which is 2, 2 minus 1 is 1, and so on and so forth. So if you observe, this is satisfied by this D. So D is the right answer for this question. Okay. So this is what, some questions we have taken. It is from the inductor capacitor topic. Now, having completed this inductor capacitors, now let us switch into the next important topic, that is your transient analysis. So transient itself, it is having very good weightage, and student used to consider this is one of the complicated and the tough topic in the GATE exams. However, if you see the kind of questions what they're asking, okay, so if you know certain standard formula and the methods, most of the question you can answer. So questions from the transient topics are not so much of skilled base. I can say the questions from the transient topics are kind of what? Method-oriented questions. You know the methods, you can answer them. So generally, there are two kind of things, you'll be encountering. So most of the cases, so you'll be getting the questions based on the first order circuits. So first order circuit means the network will contain either one energy storing element, that is L or C. So you have the circuits L along with resistors, or you have the circuit C along with the resistors. So the circuit will be looking somewhat similar to this, okay? Or it might be looking something like this. So in a first order RC circuit, the capacitor voltage is given by VCT equals to VC infinite plus VC0 minus VC infinite into e raised to power minus t by tau. Similar inductor current is given IL t equals to IL infinite plus IL0 minus IL infinite into e raised to power minus t by tau. So each equation is characterized by three factors: VC infinite, VC0 minus, and tau. Similarly, IL infinite, IL0 minus, and tau. So tau in this case is R into C. Tau in this case is L by R. So you should remember that. So intentionally, I have taken here two questions. Okay. So one is from this RC circuit, one is from this RL circuits. So here the question is, see the question carefully. In the given circuits, we are supposed to find this I naught t. What is this I naught t for t greater than 0? If I naught t is represented like A plus B into e raised to power minus alpha t milliampere for t greater than 0, then what are the value of A, B, and alpha? So this is, of course, it's a first order circuit, right? So this is a first order circuits. And in first order circuits, the method is, first of all, we should try to get what is the capacitor voltage VCT. So VCT is equals to, so the formula what we have seen is VC infinite plus VC0 minus VC infinite into e raised to power minus t by tau. So you have to get these three factors. So because we are supposed to get the answer for t greater than 0, so you have to draw the circuit for t greater than 0. So if you draw the circuit for t greater than 0, how do the circuit look like? So how do the circuit look like means the switch will be in closed state or open state? Definitely switch in the closed state, because you see here the pattern is the switch is getting closed at t equal to 0. So that means for t greater than 0, definitely the switch is in the closed state. So if I'm asking you to draw the circuit for t greater than 0, so how do the circuit will look like? So this is 24. This is 2 kilo ohms. Capacitor is 200 microfarad. So this is your 4 kilo ohm. Switch is closed as we said. And then you have this 6 kilo ohm resistor in parallel. This is your 6 kilo ohm resistor. Which current we are supposed to find? We are supposed to find this current, which is your I naught. Well, what is the technique that we'll be using in these cases, in all of these cases? So whatever might be the circuits, if it is a first order circuits, you try to get what is this capacitor voltage VCT, first of all. If you get this capacitor voltage VCT, then you may use some KCL, KVL depending on the questions, and hence you can get your corresponding answer. Okay, so first thing is to get this VCT. So in this case, you can see here, so because this point is connected to ground, so I can tell like this and this 4 are in parallel. I mean, whatever the voltage will get across this VCT, the same voltage will appear here, because I can tell this capacitor of 200 microfarad and this resistor of 4 kilo ohms are connected between two same pair of node. So this is one node and this is one node. So both of them are between same pair of node. So these are in parallel. So that means one thing is clear from this. So what is the value of I naught if somebody asks you in this particular question? Then it is simply VCT divided by 4, because the voltage is VCT and the resistance is 4 by Ohm's law, it is VCT by 4. So ultimately I have to get this VCT. So how do you get VCT? To get VCT, you need to have this VC infinite. So let us try to get what is VC infinite. So to have this VC infinite, so you have to draw the circuits at t equals infinite. So at t equals infinite, so the switch is closed or open? Definitely the switch is closed only. So if I'm drawing the circuits, so this voltage is 24. So this resistance is 2 kilo ohms. So this capacitor is open circuits. So this is your 4 kilo ohms. Okay. Switch is, and this is your 6 kilo ohms. So this is 24, this is 2, this is 4, this is 6. And switch is what? Closed only, right? The switch is closed. Switch is closed. How do you know switch is closed? By observing the directions. If you see this direction, switch is getting closed at t equal to 0. So that means definitely it is in the closed state only. Okay. So this is the voltage, which is your VC of infinite. So what is VC of infinite then you get? So I can tell in this case, so if I'm saying this is what is my current IX is. So IX in this case is 24 divided by 2 plus 4, because this resistance 6 plus parallel with 0 is 0. So the net resistance is 2 plus 4 is 6. 24 by 6 is basically 4 amperes. If Ix is 4 ampere, then your VC infinite in this case is 24 minus 2 into 4. So 24 minus 8. So that is basically 16 volts. So you are getting one parameter, in this case VC infinite. So this is basically 16 volts. Plus, now you have to get VC0 minus. So you have to draw the circuit at t equal 0 minus. So what is the change in t equal 0 minus? The switching action, which was closed, this will be open, because it is said the switch is getting close at t equal to 0. That means before t equal to 0, that is at t equal to 0 minus, switch must be in the open state. So if I'm drawing the corresponding circuits, so how it will be looking like? So this will be something like this. This is 24. This is 2. Capacitor is open. Then this is 4. Switch is your open. Okay. Then this is your 6. Okay, na? So this particular voltage is VC0 minus. This is VC0 minus. Because this is the capacitor voltage VC, and because we are drawing the circuit at 0 minus, so the corresponding voltage is VC0 minus. Now, if I tell you what is the current IX in this case, particular case, so IX in this particular case is 24 divided by 2 plus 4 plus 6. So it is 24 by 12. So this is basically 2 amperes. If IX is 2 ampere, then in this case, VC0 minus is equals to 24 minus 2 into 2. So it is 24 minus 4. This is basically 20 volts. So in this equations, VC infinite is 16 and VC0 minus is 20. So this is your 20 minus 16 into e raised to power minus t by tau. So what is your tau? Tau is basically RTH into C. C is known to you, that is 200 microfarad. But what is RTH? So from where you'll be finding the RTH? RTH will be finding from the capacitor terminal. I mean, whichever the energy storing element is there, you have to make it open circuits. And from that terminal, you have to find it. So, and what is the circuit you should refer? You have to refer the circuit which is valid for t greater than 0. So if I think that way, so for t greater than 0, okay, I'm finding the RTH. So that means in this case, because the circuit is containing only independent sources, independent voltage source is short circuited. So this is 2. So we have to find the RTH from this terminal. And this is your 4. And because we are drawing the circuit for t greater than 0, so switch is definitely closed. And this is your 6. So this is your 4. So what is the value of RTH if I ask you in this case? So naturally, there are 2 paths. So one path is this one, another path is this one. So this is 2 parallel with 4, which is 8 by 6. 8 by 6 is 4 by 3. 8 by 6 is 4 by 3. So what is tau? Tau is RTH into C. So this is 4 by 3 into 10 power 3 kilo ohms. And what is C? C is 200 into 10 power minus of 6. So this is 800 by 3 into 10 power minus 3. So this is 800 by 3 milliseconds. Okay, so now you can substitute all these values. So now if you substitute all these values, so how much you get then? So VCT is equals to VC infinite, how much you got? 16 plus VC0 minus 20 minus 16 into e raised to power minus of t by tau. So it is minus of t by tau. So this is 3 into 10 power 3 divided by 800. Okay. So this is 16. 20 minus 16 is 4 into e raised to power. So this is basically 3000 divided by 800. So this is gone. So 30 by 8 is basically 15 by 4, and 15 by 4 is 3.75. So minus 3.75 T. So this is your VCT. This is your VCT. And what you're supposed to find? We are supposed to find I naught. And what is I naught? So I naught is VCT by 4. So I naught is VCT by 4. So if you divide it by 4, 16 by 4 is 4. And this is 1. This is e raised to power minus 3.75 T. So this is what you're getting. So if you compare, so A is 4. If you compare what is B, so B is 1, because the multiplying factor of the exponential is 1. And what is alpha? So alpha, if you see, this is your alpha. So alpha is 3.75. So 4, 1 and 3.75 is the right answer, which is given in option B. So B is the right answer for these questions. So these are what, like compulsorily, if there is one question from transient topics, most likely that questions will be from a series. I mean, that question will be from a first order RC circuit like this, or it is from first order RL circuits. So the previous question was from the first order RC circuits. So now let us take one question from first order RL circuits. So in this case, the voltage VT, okay, what is VT? VT is the drop across this 6 ohm resistor. So this is expressed as A plus B into e raised to power minus 60 for t greater than 0. Then what is the value of A and B? So ultimately I have to get the value of this VT. Again, the switch is getting closed at t equal to 0. Okay. So, so it's a RL circuits. So our approach is to get the inductor current ILT. So ILT is basically given by IL infinite plus IL 0 minus IL infinite into e raised to power minus of t by tau. So in this case, first of all, I have to get IL infinite, IL 0 minus and tau. Then we'll be substituting there. So by substituting that, we'll be getting the inductor current. What is the inductor current? So this is what is your inductor current ILT. And once I get ILT, then we think. So once we have the ILT, then how do I get the corresponding VT informations? So let's first try to get this ILT. So first of all, my interest is to draw the circuits at t equal to 0 minus. The switch is getting closed at t equal to 0. So before t equal to 0, switches must be in open state. If the switch is open state, so how does the circuit look like? So this is your same 12 ampere source. This is your 3 ohms. This is your 6 ohms. This is your 4 ohms. And the inductor should be short circuited. So because at t equal to 0 minus, inductor is in short. So this is what the situation. And switch is in open state. One second. This corresponding switch is in open state. So this particular current is what I mean by the inductor current, IL 0 minus. And this is your same 6 ohms. Okay, na? Switch is open, inductor is shorted. The current through the inductor is IL 0 minus. So now if you see what is IL 0 minus, so this current 12 ampere, okay, is coming here. From this node, there are two paths. One is this path, one is this path. Okay, so this 12 ampere is coming here. So this 12 ampere is getting divided in this path and this path. So if this current is 12, then this current is also 12. So I can use the current division rule. IL 0 minus equals to 12 because I need the current in this directions. So the opposite arm resistance is 6 plus 6 is 12. So 12 into opposite arm resistance is 12 divided by sum of all. So 12 plus 4. So this is 16. So it is 144 by 16. So this is coming 9 amperes. So your IL 0 minus is coming 9 amperes. Is that fine? So similarly, we'll be finding what is IL infinite. So while finding IL infinite, what is the change? The change is, so the switching action will change. So switch action, this is your close now. And this current, I'll be calling it is IL infinite, which I was calling IL 0 minus. So this current is your IL infinite now. So how do you get this IL infinite? Any idea what is IL infinite? So IL 0 minus you already got. So now I want to get this IL infinite. Okay. So let us do one thing. Let us take this point is ground. Sorry. Let us take this point is ground. Okay. And so I need this branch current, right? I need this branch currents. So let's call this is Vx. If this is Vx, this is also Vx. Yes or no? Because this is the same sorted path. Okay. So this node is also Vx. And let's name this node is basically Vy. So if I write the nodal equations at node Y, so what do you get? So you get Vy minus Vx divided by 3, Vy minus Vx divided by 3 plus Vy minus Vx divided by 6 plus Vy divided by 4 equals to 0. Isn't it? This what is the equation now. Or if you have other techniques, you may use it. I mean, it is not mandatory that you have to solve the question this way. Not necessary. Okay, so this is one equation. So what is the other equation then we have? What is the other equation we have? Then the other equation I have is minus of 12, okay, from this segments, okay, plus Vx minus Vy divided by 3. I mean, you will get from these segments, plus Vx by 6 plus Vx minus Vy divided by 6 equals to 0. So how is that actually happening? Because this is the same node Vx only, right? This is the same node Vx. So if I'm observing this path, which the path I have shown now, so to this path, so how many branches are linked? So 1, 2, 3, and 4. So minus 12, then Vx minus Vy by 3. Then for this path, it is Vx by 6. And for this path, it is Vx minus Vy divided by 6. So you can simplify these two equations to get Vx and Vy. So once you get Vy, then your IL of infinite is basically Vy divided by 4. It is Vy divided by 4. Okay, so from this you can get the IL infinite. Similarly, if you want to get the time constant tau, anyway, tau is not necessary in this case because if you see this pattern, so it is given. I mean, if you compare with this one, I can tell from this question it is clear that 1 by tau must be equals to 6, or tau is equals to 1 by 6. So just you have to substitute. So this you have to simplify this, and I already obtained IL 0 which is 9, and then you try to get this IL infinite. Okay, so you see how much you are getting. Okay, so then you substitute this in this particular formula, ILT. And once you get this ILT, now the next thing is how do you use this ILT to get this VT? So how do you make use this ILT to get this VT? Okay, so what is the approach in this case then? Hopefully this logic is clear. I don't think you have any other doubts for this. Anybody who solved? What is the answer you're getting? So if you are feeling this is difficult, I can give you one more technique also. And the technique is something like this. So do you mind if I'm redrawing the circuit, which is something like this? So this is your 12. Okay, and then, so this is your 3, this is your 6, this is your 4, and this is your 6, 3, 6, 4, and 6. Do you mind this? Do you agree that these two circuits are equivalents? Because, like you see here, so from this node, okay, this is 3 and this is 6. This is 3 and this is 6. So there is nothing wrong if somebody, instead of connecting here, somebody is showing like this, and similarly saying 6 here, somebody is showing like this. That means somebody can show this 3 is like this and 6 this way. So I'm just redrawing it. Okay, so if you refer these circuits, so this current is your IL of infinite, right? So now in this case, I think the things will be much simpler for you. So this is again equivalent to 3 parallel with 6 is 2. So this is basically 12. And then you have this is 3 parallel with 6 is 2. And then this is 4. And this is again parallel with 6. So this current is what I mean by IL of infinite. So this is your again 12. So what is IL of infinite? So net current 12 into opposite resistance is 6 divided by 6 plus 6 is basically 12. So it is basically 6. So IL 0 minus we got 9 and we got IL of infinite. So that is basically how much we are getting, it is 6. Time constant also, if you want to get how the time constant is happening 1 by 6 also, if you want I can show you. So to evaluate time constants I need RTH. So RTH, for this you have to refer the circuit which is valid for t greater than 0. So t greater than 0 means this is what is the circuit you will get, but you have to observe this RTH from this terminal. Let me draw a separate circuit for you. Okay, so this same circuit. So switch is closed. This is 3, this is 6, this is 6, okay na? This is your 4. Inductor is open circuits because from the inductor terminal you have to see. And this is now your, what I can say, is basically open circuit because the current source, independent current source, that should be open circuited. And from here, I have to see what is my RTH. So this is 6, this is 6, this is 3, and this is my 4. Okay. So this again, if you want, you can again redraw it. So if you redraw it, how does this will be looking like? So this will be something like this. Three. This is 6. This is your 4. From here, we are observing this RTH. So this is equivalent to 3 parallel with 6 is 2. So this is 2 ohms. Okay. And from this, you have this is how much? 6, because this is 6, right? This is 6, this is 6, 6. And this is your 4. And from here, you are finding this RTH. Is this fine? This is open circuited. Okay, fine. Any mistake is happening? 1 second. Yeah, 1 second, sorry. This is 4, right? So from this, I am finding my RTH. And then Yes, this is the circuits. This is my 3, this is my 6, this is 4, and this is 6. Okay, so what is my RTH if I ask you? So if I ask you RTH is equal to 4 plus. So in this path, if you see, so again, if you try to redraw this, so this will be now simpler. There should be clarity actually, okay? That's why I'm again solving step by step. So 3 parallel with 6 is 2. So this is 2. So this is 6. Okay, and this is your 4. And from this, you're finding this RTH. This is 4 and this is 2. This side is open and this is 6. So from this, if you find RTH, it is 4 plus 2 plus 6, which is coming 12. It is 12. L is given how much? 2, right? L is 2. So L is 2. The time constant is L by RTH. That is 2 by 12, which is 1 by 6. Okay. So if time constant is 1 by 6, then 1 by tau is 6, which is given in the questions. So time constant is 1 by 6. This is what we predicted, but this is what, for your understanding purpose, I have just only simplified this way. So what is your ILT then? So your ILT is equals to IL of infinite, which is 6, plus 9 minus 6 is 3 into e raised to power minus of 60. This is what my ILT is. And this is valid for t greater than 0. And if I'm interested to find this VT, my interest is not to get ILT, my interest is to get a VT. So in that way, if I draw these circuits for t greater than 0, how does this circuit will look like? The circuit will look something like this. So this is your 12, okay? Then this is your 12. Then again, this is your 3. This is your 6. This is your 6. So this is your 4. This is your inductor. This is your 4. Okay. This is the circuit, right? This is the same circuits. This is the same circuit which is applicable for t greater than 0. And in this, we know this current ILT. This is what we obtained. So what we need this current, right? We need this current. So we need this voltage, which is VT. So if you think now, what is the logic in this case? So this circuit is equivalent to, this is 12. Okay. So this is 12. And then this is 3 parallel with 6 is 2. This is 2. This is 4. And then I have this inductor. And this resistance is 6. So this is your 12. Okay. So this current is ILT. So this voltage VT I need. So how do you get VT? So VT is equals to, by Ohm's law, resistance is 6. And if I'm saying this current is IX, so this is 6 into IX. So 6 into IX. What is IX? IX is 12 minus ILT. Hope you agree. 12 minus ILT. Because 12 is coming to this node. And out of this, ILT is going this way. So 12 minus ILT is IX. So this is 6 into 12 minus 6 minus 3 into e raised to power minus 60. So this is 6 into 12 minus 6 is 6 minus 3 into e raised to power minus 60. So if you simplify this, this is 36 minus 18 into e raised to power minus 60. So this is what your VT expressions, and it is said that VT is equivalent to A plus B into e raised to power minus 60. So if you compare now, A is 36 and B is minus 18. So A is 36 and your B is minus of 18. This is the final answer. Okay. So because I'm explaining you, I have taken around 10 minutes of time to solve this. Otherwise, if I solve this one in flow, so this should not take much more than 2 minutes. So 3 parameters you have to always obtain: IL0, IL infinite, and time constants. And then using these 3 parameters, you get ILT. And once you get ILT, then you use the KCL, KVL, Ohm's law in a skilled way to get the corresponding digit parameter. So for here, I first obtain what is ILT, right? ILT we have obtained. And once I obtain this ILT, then I have drawn the circuits for what? T greater than 0, right? And by observing the circuits, I have derived this VT is 6Ix, where Ix is 12 minus ILT. Already I got ILT. By substituting this, I'm getting the corresponding answers. So the answer is option C for this. This was all for today. And again, in the next sessions, we'll continue with something else.